Hey everyone, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale Armortek Early Production German Tiger 1. Since the last video update, a lot of progress has been made to the tank's rear section and interior portions. We'll be going over all of these additions and details in this video. With the interior engine compartment detailings now fleshing out and filling in, the one detail that is also going to be added is that of the ductwork for that of the exhaust manifold. Now, the Tiger 1 has this insanely elaborate and complicated system that cools down the exhaust smoke that gets emitted from the engine just prior from it getting emitted out through the exhaust stacks on the rear of the tank. That's facilitated with this ductwork that we have here. The set that we have here is the resin set that's found on the EastCoastArmory.com product line. The set contains 3 pieces in order to assemble the one complete manifold. Also included are several other ducts which are not shown in the scene here, but will be added shortly after the piece is primed and installed. As for the piece, again, it's made from resin and has been assembled. Now, in order to get it to fit onto the Armortek piece, I had to go ahead and bore out several sections here of the resin that are behind the plate. The reason for this is to make clearance for that of the fasteners, which are found on the inside portion, which bolt on the exhaust cover, armor covers that are on the outside of the tank. And these sections here are bored out for clearance of that of the 2 brass fittings which secure the exhaust stacks to the rear wall. With the pieces all hollowed out, this can now be primed and then mounted inside of the tank. Next to the engine, the second most important bit of equipment that gets mounted to the engine compartment is that of the Fan Clutch Gearbox. Now, with the HL210, the way the engine would connect and power the fans that are on the sides of the hull is with this system over here. The HL210 has a single output shaft, which would connect to a drive shaft, which would connect to this little location here found on this unit. Then this would turn a series of gears, which would then split the output to these 2 units, which would then have drive shafts of their own and would thus connect to the fans powering them. The unit essentially is nothing more than a miniature transmission that would have been found inside the engine compartment. Now, when the HL210 was replaced with the HL230, this system was completely replaced with 2 smaller gearboxes which would be found on either side of the HL230. As for the HL210 system, this system here is the unit found on the EastCoastArmory.com product line, and this one here was modified so that it is actually fully functional. There is a small little electric motor which connects to a miniature gearbox found on the inside here, and once connected to the electronics, the output shafts will spin, thus completing the illusion that the gearbox is being turned by the motor. In addition to that, like was mentioned in the last video, there's another output shaft which will connect to this section over here. That is connected and is powered by the engine itself. When everything is working in sync, it will give the complete illusion. Now, as for the detailing, the unit is made from resin, and we have here a filler spout for that of the oil, which is used to keep everything nice and lubricated. All the detailing you see on this component here are stock ECA with the exception of the drive shafts. The component from ECA is meant to be static display, and the drive shafts are resin detail units and are not meant to be functional. In order to modify the unit to make it fully functional, I had to hollow out the center cavity here with that of the mill, and for the drive shafts, I went ahead and found these 2 universal miniature joints, which are typically for radio-controlled cars, and these units were acquired off of eBay. They were simply mounted to the gearbox itself, and now that the unit is fully assembled, I can go ahead and get the unit into its paint and primer, to which then I could weather it and install it inside of the tank. Now, like I said before, the unit is electrically powered. Now, you'll notice the electric motor does protrude from the rear section of the transmission. The motor itself will not be seen once the unit is mounted inside of the tank, as this unit is pretty much covered up by the rear deck hinge portion found on the engine hatch and the rear deck itself. The piece is electrically driven, and the way I designed it was that I milled away recesses here inside of the rear so that the electric power cords emerge from the front. Now, these 2 locations here are found on the real unit, and on the real unit these would be used for, again, I believe, that of lubrication lines. Once everything is painted, everything will blend right in, and the lines will totally be be considered part of the detailing and will blend in seamlessly with the rest of the tank's engine compartment detailing. And here are the interior engine compartment components now fully painted and ready for installation. You'll see that the pieces have their coat of base coat added, as well as their grime weathering has also been added at this point here. As for the fan clutch system, the unit was modified slightly from the previous scene in that if we notice here, the motor no longer emerges from the rear portion of the unit. After everything was dry fitted in place, I saw that the motor sticking out was going to be problematic and was going to cause issues with mounting of the component inside of the tank. So I went ahead and revised the piece to the way you see it here, with a motor that is now flush inside of the casing. Now the unit can sit flush into the hull, which will then have everything in its proper location. Being an early production Tiger, which would have had a snorkeling capability, one feature that the early Tigers had was that the engine compartment had a cooling system that would blow cool air into the compartment. Now, the unit, because of the snorkeling, had to have shutoffs that would prevent water from coming into the engine compartment, as if we can recall on these early Tiger 1s, the fan areas would free flood, but the engine compartment itself would stay totally bone dry. To keep water from coming into the tank, that was facilitated with this valve system that we have here. There's one on either side. These units are the ECA wrestling ones, and the way they work is that there is a linkage that connects to this section here with a cable that runs inside of the fighting compartment. With a hit of a lever, these would open up, thus allowing air to flow in, and the way you see here, the pieces are modeled in their closed state. A little bit of red primer was added to the valve itself to give a little bit of accent, as well as also to have the piece pop out compared to just leaving it all with the primer gray. Now you can leave them, either or is acceptable and is appropriate for a build like this. And here's the engine compartment now ready for its detail installation. Since the last scene, the weathering has been added, as well as some more interior details. Starting with the tank's firewall vent, the firewall vent that you see here is a new addition to the East Coast Armory.com product line. This version here replicates that of the first pattern of firewall vent design. Throughout the Tiger 1's production run, there were 3 patterns of vents that were developed. Also in ECA, the second pattern is also represented and found on the catalog. This particular version here would have been for about the first 250 vehicles which were produced. Of course, this vehicle being an early production Tiger with the HL210 engine, this pattern of firewall vent would be appropriate for this model. Moving our way to the rear armored plate of the tank takes us to these U-shackles. There are 2 of these units, one on each side of the vehicle, and it's a mirror image. The purpose of these shackles has to do with the mounting and securing of the fan radiator cluster. Now, on the real Tiger, these 2 little lugs that we have here would index into 2 corresponding holes found on the fan cluster casing. On the real tank, it would index in and hold it in place, and then the radiator would then be bolted to the tank sponson via fasteners. On the model that we have here, since the tank does have interior detailing and the fan clusters are present, these units were fitted to the tank. Now, these units have been seen on several other ECA videos as these pieces are done on my build, and they are supplied with the ECA fan radiator cluster set. Now, if we notice the shape of them, you'll notice that there is a cavity in the center. The purpose of this cavity is that when the Tiger 1 was originally developed, there was supposed to be a hydraulic actuator which would open and close on demand the rear hinge section of the Tiger 1's fan grills. This unit was never developed past the drawing board, and even though the unit was never installed or ever developed, the shackles are still present and kept the exact same design from the beginning of the Tiger 1 all the way up to the end and last produced Tiger 1 variant. As for the rest of the engine bay, detailing is untouched since the last video with that of the lower hull fuel tanks. As you can see, the weathering has been added, and it's the same type of grime weathering that was added to the detail components, which are to be added to this section here that was mentioned in a previous scene. It is at this point now where I could start adding the interior component detailing. Now, just like with the road wheels, when it comes to installing an engine bay and engine bay interior detailing, everything needs to be done and assembled in layers. Here we have the empty compartment, which is now ready for that of the installation of the Maybach HL210, which was of course mentioned in an earlier video. Now, regrettably, while I was doing all the installation process, I neglected to get this on video, so I'm going to have to go over as well as I can the installation process with everything already installed inside the engine compartment. The first thing to be added, of course, was that of the ductwork that we have here on the back. The duct simply slides over the stock Armortek fasteners for that of the exhaust manifolds, which were showcased in an earlier video. After the duct was installed, the engine was then mounted permanently to the engine bay. As for the mounting procedure, this is done exclusively with that of fasteners. You can see here two fasteners which secure the front of the engine to the firewall. And then on the lower portion of the hull here, we have two more fasteners which connect to the actual engine stand, which is built into the Maybach HL. Now, in addition to the fasteners, you'll see I utilize neoprene rubber washers. The neoprene rubber washers are used on several locations for this application. We have here two on the exterior, and there are another 2 or 4 found on the interior portion. Basically, it's what insulates the engine from that of the tank itself. The reason why I went ahead and used these neoprene washers is that the washers act as a sort of shock absorber and do help the engine deal with some of the vibrations, as opposed to hard mounting it directly to the metal tank. Because of both the tank being radio controlled, in which it's going to bounce around and rumble with that of the, when the tank is driving, there's also the vibrations from the actual animation of the engine itself. With the use of these rubber neoprene washers, this helps to absorb and deaden a lot of these small vibrations, which can possibly lead to issues down the road. Now, as you notice, the fasteners do descend quite heavily from the lower plate of the tank, and of course these will be dealt with shortly after the filming of this video. Now, as a side note, it's important also to point out that the real Maybach HL 210 and 230 engines had a system very similar, in which the engine stand was actually suspended from the tank's bottom plate with that of 2 large rubber shock absorbing type bump stops, in a very, very similar way for the exact same application that I have on this model here. Back onto the interior portion of the compartment, we takes us back here to the cooling duct. Now, if you notice, emerging from the coolant duct is that of this 90-degree elbow. This elbow enters into the fan compartment and connects to a hole that is found on the bottom portion of the fan cooling housing. Directly below the elbow is a rusty heat shield. Now, this is a mirror image on the opposite side of the vehicle, and the way this system works has to do with that of the cooling system. Besides the cooling fans, which are used to cool down the radiator fluid that gets pumped into the engine, another purpose that these fans are used for are actually to cool down the engine smoke, which comes off of the manifold itself. The reason for this was that one of the fears that the designers had was that when the engine compartment buttoned up, the hot manifold exhaust smoke was going to be at an accelerated temperature due to the fact that the engine will be running for a while, and again, in combination with being sealed up. Because of these excessive temperatures, there was a fear that the engine could possibly overheat, or something could actually cause a fire, or possibly even melt down. None of which is a benefit to this situation. So early on, the designers went ahead and developed this cooling system that we have here. The way the system works is that air from the fans gets pumped into this elbow section here, which enters into this large duct, and this helps cool down the exhaust smoke, and as well as aerate out the exhaust manifolds on either side of the engine. This also aids in helping to blow out the exhaust smoke itself from that of the exhaust manifold. In addition to the small little duct that we have here, there is another fan which would be located on the real Tiger just aft of the Firewall, and that's why we have this little blister that emerges from the Tiger 1's engine compartment. On the real vehicle, there would be a large propeller on the inside portion. This propeller here would be tied into the tank's drive shaft, and when the drive shaft is turning, it is pumping air into the engine compartment. This is done to the engine compartment, but also, I believe, into the main fighting compartment as well. It adds some sort of ventilation. The air, again, funnels through the exhaust manifold from the front now, and propels all the way out, and again, aids with keeping the exhaust manifold nice and at a controlled temperature, as opposed to having them overheat themselves due to the combustion of the engine in operation. Moving from the ductwork takes us to another ventilation system that is found on the engine compartment, and that is found on opposite sides of the compartment that face the engine. You'll notice here that there is a drum with a control linkage and clevis. This was showcased in an earlier scene when the pieces were painted and weathered. However, as you can see on how they fit into the system, this little section here helps again open up the engine compartment for that of ventilation from that of the fan system in itself. So the fans, again, aid in both cooling down the radiators as well as pumping cooler air into the exhaust manifold, and also aids in circulation of air inside the engine compartment in itself. Now, another thing to point out is that on this model here, you'll see that they are able to be shut off via a linkage for that of snorkeling capabilities. And it's important to note that once the snorkeling capabilities were dropped, the vent was still retained inside of the vehicle's engine compartment. However, the linkage system was deleted. And this vent is found on all Tiger 1s with the HL210 as well as the HL230, just again with or without the linkage connecting mechanism. Once the engine and the ductwork was done, it was then time to turn my attention to that of the cooling fan transmission system. Now, this was the same system that was mentioned before, and of course, like I mentioned before, is fully motorized. The way this is affixed to the vehicle is with fasteners direct. The holes were marked, drilled, and tapped, and is bolted directly to the rear plate of the vehicle. Now, you'll notice that the piece is also suspended on neoprene washers, and these aid as both as a standoff to have the transmission now make direct contact with the rear hull, as there are some electrical connections back here for that of the motor, but also for that of proper alignment. And again, the neoprene washers help as a denting device and keeps vibrations down to a minimum, again, due to the operation of the gearbox for the transmission, as well as, again, from the tank rocking and swaying during operation. Now, some details that need to be added are these two control rods which will emit from the Firewall, work their way down the sides of the engine, and come to this little mechanism over here that is mounted adjacent to that of the drive shaft for that of the fan clutch system. There's going to be one on each side. This will be added in the next video update. The purpose of this mechanism here will be for, on the real Tiger, to disengage the drive shaft from that of the fans, so that when the tank goes into its snorkeling mode, this unit here continues to spin, but the fans are no longer spinning when the tank is snorkeling. Because this is a early production Tiger 1 with the HL210 engine, this tank would have had the ability for the snorkeling capabilities. Moving to the side, we have here some control boxes. These electrical boxes here, I believe, connect to the spark plugs. However, I might be mistaken. Either way, on the HL210, it's important to point out that there are 4 of these units present. And on the HL230 engines, there's only 2 of these boxes present, so they were able to refine the design and omit 2 of these units, thus saving material. Here we have 2 coolant lines which emit from the sides here of the engine. Then run up into the rest of the coolant system. Now, the coolant system on the Tiger 1 is a very elaborate system, but is actually also quite simple. but it does add a lot of clutter to the engine compartment in itself. This is true for both the HL210 and the HL230, as both of these engines shared this exact same system, and it really wasn't changed throughout the production runs of the vehicle. Now, moving from the engine compartment now takes us to the fan compartments. It is at this point now where I can go ahead and mount the fan and radiator clusters to their appropriate locations. Now, one thing I did, if you'll notice, I have the wire that comes from the clutch gearbox. Each side has a positive and a negative wire on the opposite side, and they run along the fan compartments, which will emerge from the inside of the vehicle. Thus, I can go ahead and do the wiring after this detailing is all mounted. The wires are hot glued in place to keep them nice and clean and to prevent them from moving around and causing clutter. Now, on this side of the vehicle, you notice I have two more wires that run along the side here of the hull and emerge from the outside portion. The purpose for these two wires here is that of the convoy light, which will be added and will be fully functional. This function will be added shortly after the filming of the scene, when I start ironing out the electronics and I get to the head lights, which this unit here will definitely be patched into that circuitry. More information on that is to come. Now, with the engine compartment basically out of the way, it's now time for mounting of the fans. As for the cooling fans, these are the same units that were showcased in an earlier video. The only change that has been made to them is, if you notice, their final weathering has been added. And also the details on the top portion have been fitted as well. On this radiator here, which will be located on the driver's side, there is a refiller cap, while on the opposite side, there is a cap that is bolted into this little channel with a bleeder valve stem that we have. This is, again, as per the real unit. Now, as for the installation of the fans to the vehicle, this will be done with the use of silicone, and the purpose of the silicone is that it firmly secures the units in place, but it is a temporary bond in which, in case there's an or some kind of an accident, an emergency, and you need to get access into the idler mount system here, you can remove the fans without causing any permanent damage to the vehicle or to the fan housings themselves. They will simply get mounted in this manner to the lugs that I showcased earlier on in the video. As for the silicone, I'll be adding a somewhat liberal amount, and I'll be adding it to the bottom portions. You don't want to add it to the sides, as with the way the units need to be mounted into the compartment, they need to drop in and slide in for them to be seated. And obviously, if you put the silicone on the sides, it's going to create a bit of a mess, which will definitely be seen, by the way, through the grills, which is something that is less than ideal. With the silicone mounted on the bottom, I can now line everything up, slide everything in place, then press down, and the units are now mounted to the compartment. It is at this point here where I can go ahead and connect the plumbing system, which will then fully complete these pieces further. And here are the radiator clusters now with the coolant tubes added. The tubes that you see here are the supply ones with the ECA sets. Now, one change that has been made to the ECA set is with the actual tube material itself. In the past, the tubes that I would have supplied were that of the yellow surgical tubing, which would need to be painted by the end user and then mounted to their appropriate locations. This was doable, however, it was a little bit more problematic in terms of painting. Since then, I've swapped out the yellow tubes and replaced them now with black surgical tubing, which is a lot easier done for that of the installation and used by the end user. All ECA sets from this point on will utilize the black revised tubes. This is true for both the ECA fans as well as the ECA engine accessory sets for both the HL210, which is what this unit is, and the ECA HL230 engine accessory sets, which are also again found on the ECA product line. Here you can see the radiator detailing on both sides. Now, the last bit of detailing that needs to be added to these two areas over here, and if anyone is a frequent viewer of my channel, you'll instantly know what I'm referring to, and that is of the air ducts, which are located in these two sections here and on the opposite side. On the real Tiger 1, as I often mention, this area here would be utilize that of the main fuel tanks, which are of course on both sides of the upper hull here of the sponson. As you can see, it is a quite substantial size location and would utilize a very large fuel tank. Tiger had 4 fuel tanks total, 2 on the sponsons, and the other 2 are besides the engine on the under portions of the lower hull. Now, like I again frequently mention, the fuel tanks are not going to be built into this model here as they are not seen on the actual tank. The reason for which is that on the real tank, again, there is a large sheet metal air duct which is located in this section over here, and this air duct is used for 2 purposes. It funnels air into the radiators in a nice clean motion, and it also acts as a shield protecting the fuel cells from any sort of damage from things like small arms fire or even shell explosions from that of air bursting munitions. Now, in the past, the ducts would be fabricated out of sheet steel and are all soldered together. However, on this model here, I'm not going to be utilizing that version. Instead, I have 2 new sets for these components, which are going to be made of 3D printed material. These units are currently, at the time of filming this video, in production at the printer, and as soon as I have them, I'll have more information about these to come. So it's definitely going to be a very interesting bit of detail and kit that will be posted on the ECA product line. Again, more information about this will come in the next video update. Now, like what was showcased in the last video, the engine is fully animated with its animations on both the main flywheel as well as on the output shaft that connects the engine to the transmissions for that of the fans. Now, I also showcased earlier on in this video that this unit here is motorized and has a miniature gearbox on the inside for use of the animation. To test run the piece, I have here a battery, 7.2 battery, which I'm going to hook up the leads just for testing purpose. With the piece hooked up, you'll see the animation in action. And once spinning will give the illusion that the engine is actually turning the transmission, which will look like it's turning the fans with everything connected, patched in. Now, currently all the electronic systems at this point are separate and are not patched in yet. This, of course, is going to change over the course of the build, which will also be discussed more than likely in the next 1 or 2 video updates. Connecting the leads. And here you can see the unit in actuation. Another tip to point out for anyone who is interested in building an engine compartment on their 1/6 scale Tiger, be it in a Armortek like this one, or a Field of Armor, or even a scratch build type model, anytime you're dealing with an engine compartment, you have to keep in mind of the height of the roof. I say this because there's a lot of detailing in here, and one could easily become complacent with the way it looks with the top plate off of the model. And if you build the piece without keeping in mind where the ceiling is, you can easily run the risk of overstretching it and the piece making contact with the upper deck. If this happens, there's really no easy way or solution to resolve this other than basically ripping everything out and starting from ground zero. Fortunately, this was one thing I paid a lot of attention to when I was designing and building this piece here, and when I put the engine compartment rear deck plate on, everything fits as it should. There is no portions of the air filters which are protruding past the top deck, and with the way this kit is designed, the engine hatch sits on top of this plate here, so nothing descends into the compartment past this point. Moving on from the fan transmission now takes us to the engine's cooling system. Now, the HL210 as well as the HL230 were both liquid cooled engines, and because of which needed a liquid cooling system. Now, this is one system on the Tiger one that is particularly very interesting to me, and I always found it to be absolutely fascinating. The way the system works is that you need 2 of these radiators, and the coolant flows from one radiator through the engine compartment and into the other radiator, thus then back into the condenser, which is located on the bottom of the engine, which is showcased on the previous video, and then from there it enters into the circulation of the vehicle. There are also two more cooling systems that emerge from the rear portion here of the rocker arms. They run their way up into these sections here, which then circulate again into that of the radiators. Now, as for the cooling system, it starts off really on this side and this side here of the engine. These two spouts here are where the hot water would emerge from the cooling system. The warm water would both converge to a center-mounted location, and then from here, they would flow into this tube, which would then enter into the first radiator. Because this radiator here gets the first initial hot water from the engine, this is why this radiator here does not have a removable cover cap. If we notice, the cover cap is held on with that of fasteners and is also the portion where we see the steam bleeder valve that we have here. The water would enter into this radiator. The fans, of course, would then blow the air in, which would cool off the water. The water would condense, flow down to the bottom portion of the radiator, to which then it would enter back into the engine compartment. Now, it's difficult to see with all the equipment in the way, but there is a small tube that would emerge from the wall, run its way along the engine compartment, and then it would merge upward and go into this tube section that we have here. The water would enter up, snake around, to which then it would enter back into this portion of the radiator, and it would cool down. If we notice, because of the cooler temperature on this section here, this cap here is more easily removed with that in order to top off the water cooling system. This cap here would be just like your average cap found on a radiator on a car or a tractor or what have you. The water would then, of course, cool down further with the aid of the fans and then pumped back into the engine compartment via another small tube that would enter from this side, to which then that one would go down and connect to the condenser tube, which is found built into the Maybach engine. Now, this system is identical to the way it is on the HL210 as it is on the HL230. The only difference is that with the way the funnels emerge from the engine itself, on the 230 is slightly different. I strongly recommend checking out my older late production Tiger 1 video, in which I go over the cooling system, how it connects on that model. For this one here, the cooling system is, again, as you see it, configured for an HL210. Now, the HL230 also has these two auxiliary cooling tubes, which emerge from the side portions here of the rocker arms, and then they would make contact and enter into the cooling system via these two sections over here. Then there is also this other tube, which zigzags along this portion here, and they connect to the back portions of the cooling tubes. This is also, again, true for the 210 as well as it is the 230. Now, like I said before, there are 2 or 3 more components that need to be fitted to the interior portion of the engine compartment, with the addition also, of course, the fan ducts. All these pieces are going to be discussed in more detail in the next 1 or 2 video updates. However, with the engine compartment at the point that it is now, I can really turn my attention now to the rest of the model's electronics. More information on this is to come in the next video update. Before I depart, though, I will say that the completion of this section here of the model marks a huge turning point in the build, as this is definitely something that clearly takes a lot of time and resources to fully assemble, build, and execute. With all of the basic heavy lift work out of the way, I can now focus the rest of my attention on the rest of the build, getting this guy up and running. And with that, that wraps up this project update video for this 1/6 scale radio-controlled Armortek Early Production German Tiger 1. If you like this video, stop by and like us on Facebook, where there are more photographs of this particular build that have been posted all the way from its project start, as well as the other smaller and larger scale builds that have been showcased on the ECA channel. In addition to that, don't forget to swing by eastcoastarmory.com for more 1/6 and 1/16 scale builds and detail components. Thanks for watching.